What's up, Math One? I apologize I couldn't be there today. So here is the video to get you guys going on the homework and keep you on pace in the course. So yesterday in class we talked about like this whole adding to one side, subtracting from another, writing two equivalent expressions like we did in number 4, 5, 6, and 7. You guys did a really good job, right? When do we add? What rectangle are we finding the area of? So now, after doing all of that, question 8 brings us to, it says, an expression that has three terms in the form ax squared plus bx plus c is called a trinomial. Okay, look back at your trinomials you wrote in 3 through 7. How can you tell if the middle term is going to be positive or negative? Pause the video, if you have not answered that question yet, and take a look at it. All right. Now, someone in third hour today came up with a good explanation. If you look at this, here we're adding 2, subtracting 3. Here we're subtracting 3, adding 4. We're subtracting 3, adding 4. What happens is the pattern you should notice is if the bigger number is negative, we say b is negative. All right. So that middle term would be negative. If the bigger number is positive, b is going to be positive. But someone said that they broke it down to what are you adding or subtracting to each side? That is even more valuable. Meaning here we're subtracting more than we're adding, therefore it's going to be negative. Here we're subtracting more than what we're adding, so it's going to be negative. Here we're adding more than we're subtracting, therefore it was positive. And that's exactly a very good way to put it. Okay. So number 9 says, one customer had an unusual request. She wanted a block that is extended 2 inches on one side and decreased by 2 inches on the other side. Okay. So you have this block, right? And on one side, we're going to increase it by 2. And then on the other side, we're going to go ahead and decrease it by 2. Okay, so we know we're cutting this off, right? So what ends up happening here? Well, if you look, this side is x minus 2. This side is x plus 2. Okay, so if we were to go ahead and write it out this way and do what we're good at, and that's foiling, right, we would see that x times x gives us x squared. X times 2 is 2x. Negative 2 times x is negative 2x. Negative 2 times 2 is minus 4. But look what happens when we have this in the middle, right? We end up getting x squared. This adds up to 0x. They eliminate. And then we're left with minus 4. So it says, one of the employees thinks this rectangle will have the same area as the original square, since one side was decreased by the same amount as the other side was increased. What do you think? And the answer to that is no, because this is the original square, and all we're doing is subtracting 4 units from that. Okay? So it doesn't end up being the same size. Okay? So let's go ahead and look at the next one now. Number 10. And number 10 says, the result of the unusual request made by the employee curious. Is there a pattern or a way to predict the two expressions for an area when one side is increased and the other is decreased by the same number? Try modeling these two problems and look at your answer to number 8. Again, what happens is if you go back to the last example, you'll see the positives, what you add, always takes away from what you subtract. So no matter what here, if I FOIL this out the long way, x times x is x squared, right? X times negative 1 is minus x. 1 times x is plus 1x, right? And then 1 times negative 1 is minus 1. What ends up happening here? These eliminate. And I end up with x squared minus 1. So without writing this all out now, is there a pattern that we can see? Well, the middle terms always eliminate, don't they? So can we do a shortcut here just by multiplying the first two and the last two? Now you have to know this pattern only exists when you add the same amount and subtract the same amount to each side of the square. Okay? So this here, right? What pattern did you notice? Well, we noticed the middle term always eliminates. And what is the result of this going to be? All you're going to do is multiply x and x to get x squared. A positive times a negative is always going to be a negative. A times a is a squared. So that is a pattern you would recognize. This is what we call a sum and difference problem. Okay, they happen, but not often. So now the next one, some customers want both sides of the block reduced. Draw the diagram for the following blocks and find the trinomial expression for the area of each block. Use algebra to verify the trinomial expression that you found from the diagram. Okay, so we look here. Here's my original square. I'm going to subtract 3 here. And then I'm going to subtract 2 from here. So what happens here? What do we end up with? Well, when we subtract all of this and we subtract all of this, how does this work out? Well, if we do what we know algebraically, x times x is x squared. X times negative 3 is minus 3x. Negative 2 times x is minus 2x. But then negative 2 times negative 3 is plus 6. So we end up getting x squared minus 6x, right? Or sorry, minus 5x, sorry, plus 6. So what happens is these little blocks here turn into what? They turn into positives. We don't have any negative and positives to cancel each other out here. So we have to fill this in, right? So if we take all of this out and all of this out to keep it a rectangle, we'd have to fill it back in, right? Because it would end up canceling too much out. So these end up turning into positives. And if you think about it, x minus 3, this side's x minus 2, x times x is x squared. Then you have 3 negative x's here, negative x, negative x, 2 here, so you get your minus 5x. But then negative 3 times negative 2 would make these positive 6. Okay? So the next one, very similar, right? X times x is x squared. X times negative 4 is minus 4x. Negative 1x is negative 1x. Negative 1 times negative 4 is positive 4. And that gives you x squared minus 5x plus 4. Remember, if you're not adding and subtracting, to make it a perfect rectangle, we have to fill it back in if we're subtracting twice. How much are we filling back in? 4. Okay. So look back at over all the equivalent expressions that you've written so far and explain how to tell if the third term in the trinomial expression ax squared plus bx plus c will be positive or negative. If you have not taken the time to look at this, how would you determine, right? Well, no matter what, if both signs are the same, meaning plus a x plus b, if both of them are subtraction or both of them are addition, what's going to happen? C will be positive. But if you have x plus a, x minus b, or x minus a, x plus b, if these signs are different, right? If these are different, a positive times a negative, what's going to happen is your C will be negative. Okay? Very important to understand, especially for this next section. Okay, so let's take a look at the next part. So, says Optimus Quilt Shop has received a number of orders that are given as a rectangular area using trinomial expressions. Find equivalent expressions that show the length of the two sides of the rectangles. So we know, right, we have to split this up and force the rectangles. Some of us have really adapted well to creating the rectangle by adding and subtracting and trying to make sure we have 18 little ones to fill in. But we also did a shortcut where we said all we have to do is find the numbers that multiply to give us 18 and add up to give me 9. What numbers make that happen? Well, we know we have 18 and 1, 9 and 2, 6 and 3. But which one of these set of factors add up to give you 9? 6 plus 3 gives you 9. So an equivalent expression here would be x plus 6 times x plus 3. But now what makes the next one tough, right, is now we have to multiply to get a negative. Multiply to get negative 18 and then add up to give you 3. But what do we know about the signs of this? We said in the last exercise that right away, if C is negative, that tells us we have to have addition and then subtraction. So basically, if we know our signs are different, we really are going to add to get or subtract to get positive 3. So just write all the factors down. We know it's 18 and 1, 9 and 2, 6 and 3. Now, which ones could force, right? Could we add or subtract to make it a positive 3? Well, negative 18 plus 1 would give you negative 17 is not going to work. If I change that to positive, this to negative, right? 18 plus negative 1 is going to be 17, not work. Boom. Negative 9 plus 2 is negative 7, no. Positive 9, negative 2, it's going to give you 7, no. But then if I have negative 6 and 3, negative 6 plus 3 is negative 3, but negative 6, but 3 minus 6 or plus negative 6 would give me negative 3. Which one do I need here? I need it to add up to a positive. Therefore, 6 plus negative 3. Oh, that's one that works. Positive 6, negative 3 is what works. Right? So now again, it's a lot of trial and error. Here, you know your signs are different. Both of these are x's. One's positive, one's negative. If you remember, the more we subtract from one side, if we go back to the earlier exercises, is what the sign's going to be. So what numbers multiply to give you negative 18? These are your factors, right? But you need it to subtract to give you 3 now. So minus 6 plus 3. Now, what multiplies to give you positive 18 and adds up to negative 9? We know both of our signs have to be the same, x minus and x minus. So I do negative 18 times negative 1, that's positive 18, negative 9 times negative 2, negative 6 times negative 3. Which one of these adds up to negative 9? Negative 6 and negative 3. So it's x minus 6, x minus 3. And I can always check my answers by foiling it out. Okay, couple more, right? Here, what multiplies to give you 4 and adds up to negative 5? Sometimes we forget the easiest one. Signs are both minus because we have to multiply to get a positive and add up to a negative. So x minus 4, x minus 1. The next one, signs are different, right? So it's x minus 4, x